In this video, we are going to describe motion using velocity time graph. A velocity versus time graph is a graph of velocity on the y-axis and time on the x-axis, and the slope of the graph will give you acceleration A. So if you have a velocity versus time graph that is going straight up like this, in this situation, the slope, which is the acceleration, is a constant, and this value of acceleration will be positive. So anytime you have a line going up, that means acceleration is constant. Constant means value of acceleration will remain the same. It is not changing, and this value will be positive. So velocity is increasing and hence acceleration will be positive. Then if you have a velocity versus time graph, which is going down like this, velocity value is decreasing. In this situation, acceleration is still constant, but this time its value is negative. Then if you have a velocity versus time graph, which is a sleeping line, a line that goes parallel to time axis like this. In this situation, acceleration becomes equal to 0 and velocity is constant. So when I say velocity is constant, its value remains the same. It is not changing with time. So whatever value of velocity is here, it remains the same throughout. And if velocity is constant, acceleration will be 0. Next, if you have velocity versus time graph, which is a curve, in this situation, acceleration is changing. It's no longer constant. It will be changing if it is a curve. Now, how do we apply this to solve problem? So let's take an example. Here you have velocity versus time graph, and you need to answer these questions. First question is asking you, when is the acceleration 0? Now, acceleration will be 0 wherever you can find this sleeping line, the sleeping line or a horizontal line. So this kind of line which is parallel to time axis, a straight line parallel to time axis, this will give you acceleration 0. And this is only present in region B here. This is the only line which is parallel to time axis, or it appears to be sleeping. So these kind of lines are called sleeping, which is also called horizontal. Horizontal means a sleeping line, a line which is on the x-axis or parallel to x-axis. And a line which is standing straight, this is called vertical. So if you see a sleeping line, acceleration over there will be 0. So I will choose the answer to be option 2, which is B. Then in the second part, they're asking you, when is the acceleration negative? Acceleration is negative if the line is going down in this manner. So wherever the line is going down, acceleration in those regions will be negative. So those regions are region C here and region D. The line is going down. So in our option, we have C. We will choose the answer as C. Both C and D are going down, but in the options, we only have C. So I choose the answer to be C. Then we need to find when acceleration is positive. Positive acceleration means the line must be going up. Now, if the line is going up, acceleration is positive, and that is happening in region A here and region E. So my option has only A, so I will choose the answer as E. So if the line is going up, we take acceleration positive. If it is going down, we take it negative. And if it is a straight line parallel to time axis like this one, we take acceleration 0. Next question. Given a graph of velocity versus time, what does the horizontal line represent? So horizontal, like I said before, is the sleeping line. A line which is parallel to time axis like this. So which one is horizontal here? The only sleeping line is line A here, this one. And horizontal line represent that acceleration at this point is 0. And if acceleration is 0, that means velocity here will be constant. Velocity is not changing with time. So my answer should be something which says that velocity is constant. So in your exam, you should look for this word. If you have a straight horizontal line, look for the word constant. So in these options, only option B has constant velocity. So the answer should be object is moving at constant velocity. Next, we are going to compare the value of acceleration. Now, in a velocity time graph, like we discussed before, slope of the graph will give you the value or magnitude of acceleration. Higher the slope, higher will be the acceleration. Lower the value of slope, lower will be the acceleration. So whenever you see a velocity versus time graph and you see these lines, whichever line has a steeper slope means something which is rising faster, something that has a higher value of slope. So if you see a line which is steeper, which is rising faster, those line will have large acceleration or greater value of acceleration A. Now, how do you understand if a line is steeper? So if I were to compare red and green line, imagine if you were to walk on this line, which line would be difficult for you to walk? It is much easier for me to walk on the green line compared to the red one. Whichever is difficult to walk on or whichever is hard to walk on, those lines are steeper and they have a higher slope. And if they have a higher slope, they have higher value of acceleration. So here the red line has greater acceleration compared to green. So steeper the line, higher will be the acceleration. Now here in the question, they are asking us, what does the slope of velocity time graph represent? Only when you have velocity versus time graph, the slope represents acceleration. Whereas if this graph was position versus time, position on y-axis, time on the x-axis, in that situation, the slope will give you the speed or velocity. So answer for velocity versus time graph, slope is acceleration. But if this was position time graph, it could have been speed. Next, we need to find which car has highest acceleration. So like discussed before, whichever line has greater slope or whichever line is more steeper, difficult to climb on, that line will have higher acceleration. So if I compare 1, 2 and 3, 3 is the one which will be the most difficult to walk on, or it has the highest slope or the steepest slope. So line 3 will have higher acceleration. Line 1 has zero acceleration because it is a sleeping line, horizontal line, line parallel to time axis. So here acceleration will be 0 and here acceleration is highest. So the car which has highest acceleration will be car 3. If you ever get confused between which line is steeper, find the slope for each of them. Once you find slope for each of them, you can compare. Whoever has the highest value of slope will have greater acceleration. Then we discuss the last part, where we learn how to find if the velocity is changing direction. Now, in a velocity versus time graph, if you have a line that goes from positive values to negative, or it is going from negative to positive, whenever a line crosses the time axis, it goes over the time axis. In this situation, we say that the velocity is changing direction. So anytime your velocity values goes from positive to negative, negative to positive, or it crosses the time axis, in that case, we say it is changing direction. So here you have an example where they are asking you what happened to the motion of object at point C. Now at point C, there is a change in direction because before my velocity was negative, it's in the negative side, and then it moves to the positive. And C is the point where that change is happening. So velocity is changing direction. So I need to look for an option that says change in direction. So let's look for those two things. Change in direction is present here and change in direction is present here. I need to choose between option A and C. Now option says objects stop to change direction, then continue moving with the same speed. Same speed means velocity is not changing, which is not the case here. You can see velocity value is increasing because the line is going straight up. If it is going straight up, velocity is increasing. If velocity was same, it should have been a sleeping line, but that is not the case here. So this cannot be my answer. Next one says direction is changed and object accelerated. Object accelerated means object was either speeding up, slowing down, or changing direction. So here direction has been changed and object is accelerating. So answer will be option C. Then we have a velocity time graph which represent motion of 5 runners in a free marathon. Which one of the runners changed his running direction during the marathon? So again, changing direction, I need to find a line which crosses over the time axis. If this is your time axis, I need to find a line that crosses the time axis like this. So that is only happening in case D. Line D was initially negative, it crossed the time axis and became positive. So the answer should be run D. So this is how you can use velocity versus time graph to describe motion.